What's up, everyone? This is LeetCode 721, Accounts Merge. This problem is actually quite difficult. I will tell you that from the start. Um, so I'll try and go slow and explain things as best I can without making this video too long. But here we go. So we're given a list of accounts where each element in the accounts array is basically a list of strings, where the first element within that actual element is a name, okay? And the rest are emails. So I will copy and paste this just to show you what exactly this means, okay? Okay, so what this basically up here is telling you is that we have an array called accounts, right? And within this array, we have other arrays, okay? And in these other arrays, the first element is a name, and then what follows is a bunch of email. You can see this array also, name, bunch of emails, name, bunch of emails, name, bunch of emails. Well, these only have one, but you get my point. And we want to merge these accounts, and two accounts belong to the same person if they have a common email. Note that two accounts have the same name. If two accounts have the same name, they may belong to different people, as people could have the same name, right? If a person can have any number of accounts initially, but all their accounts definitely have the same name, right? So it also says, after merging the accounts, return the accounts in the following format. The first element of each account is the name, and the rest of the elements are emails in sorted order. The accounts themselves can be returned in any order. Okay, so this problem statement may be a little bit tricky, so I'm going to explain basically what this problem is asking you. So we could have two people named John, right? Let's say a young guy named John and an old guy named John. So these accounts don't necessarily belong to the same person, but they could, right? And how do we know if they belong to the same person? Meaning, how do you know maybe the guy who's the old guy named John, maybe he has two accounts. Well, how would we know if these two Johns are the same person or if they are different people? And that's where the emails come in, right? So because these share the same email, right? You can see John Smith at Gmail, John Smith at Gmail. We know that these Johns actually are not separate people. They're the same. So technically, this John here, he has this email and this email, but he also has other emails, right? He has this email, which obviously is up here, and this email. So they're the same people. This John is the same person. He just has two different accounts. So what we need to do is we need to merge these, right? So we're going to basically take all these emails and put them up here. Of course, we're not going to include this because it's already up here, right? So technically, when we merge, right, we're going to get something like this, right? We're going to delete this. So we did the merging. Now you can see there's another John here, but he has this email, and this email is not up here anywhere. So technically, this is what our merged account should look like, right? And let me copy this output, show you if we're correct. Okay, so this is what our answer should look like, and as you can see, that's actually what we did. So we did the merging. Now, kind of like running through this by hand is very simple. I'm just doing this to show you basically what the problem statement is asking. Actually doing this programmatically, that's kind of obviously the tricky part, right? We have a list of lists, right? An array of arrays, vector of vectors, depending on what language you're using. But that's kind of the tricky part. And how would we approach this programmatically? We now that I showed you, we kind of understand how to approach this kind of logically. But how would we handle this programmatically? Like, what conditions would we check? How would we do this, right? So moving back a little bit, right? When we're here and I said, wait, this email belongs to this account, right? Well, we're going to have to keep track of that because we need to know if an email exists somewhere else, right? And so the way we're going to do that is basically a hash map, right? Where the key is the email and the value is the account index, right? So that way we can kind of map certain emails to certain accounts. And if we encounter an email more than once, we know, okay, this email actually belongs to this other account, yet it also belongs to this account. So that means these two accounts must belong to the same person, and we need to basically merge them, right? And the way we're going to do a merge is through this, right? It's through the disjoint set data structure, also called the union find data structure, the merge find set, right? And so this will allow us to merge two disjoint sets because we know there's overlap. So this is kind of a good illustration, right? These are just basic discrete math type things. If you've taken discrete math, you will know. If you don't, it's okay, but like set theory stuff, right? Or for, these would be disjoint sets. If, for example, A has the values 1, 2, and 3, and B has the values 4, 5, and 6, right? There's no overlap in elements, so they're disjoint sets, right? But let's say we have something like this, right? Where let's say X has the values A and B, and Y has the values B and C. Well, there is overlap, right? So they're actually joint sets. And that's basically what we're doing is in this problem is that we're basically assuming all these are disjoint sets initially, right? And when we see this overlap in emails between two accounts, we know that they're actually not disjoint sets anymore. They're joint sets. So we have to join them and merge these accounts together, right? And that's basically what we're doing in this problem at kind of like a high level. And so the way we would do this is basically we're going to assume that all these accounts are essentially disjoint sets initially, right? So this account is its own entity base, right? Like John, right? John has these emails, right? So it's basically its own entity. Now this John, we're also assuming is its own entity, right? But when we go here, we see there's overlap between this and this. So when we go here, we know, wait, this actually is not its own entity. This is actually an entity of this, right? And so that's how we would do the merging, kind of like in like kind of like a more abstract way. That's basically what we're doing, right? We know, okay, this is actually not its own entity. It belongs to something else, which is this John, because these are not, again, disjoint sets anymore. Found that they share an email, right? Mary, of course, is a disjoint set, right? She does not share an email with anyone. And this other John here is its own entity, right? He's a disjoint set. He doesn't share an email with any of these Johns. So we know this John down here is actually a separate John. It's not referring to the same person here. So Mary, it's basically its own entity. So is this John. Okay. I know this is a little abstract, but yeah, union finds a little bit hard to explain, but I hope you can understand kind of what I'm getting at, as well as like there are other videos out there. There are more resources if you're lost, but at a high level, that's basically what we're doing. Okay, is we're assuming these are all disjoint sets, and when we find something that proves okay, these are not disjoint sets, we need to basically merge them. Okay, that's what we're doing. And by the way, that's why I said we're gonna have a hash map where the key is the email. That's why the account index, right? The account index is the value in the hash map, because an email points to whatever the account index is initially, right? So when we encounter an email initially, it's going to point to whatever account we found it on. But if we encounter that email again, it's not going to point to where we're looking at, because if we encountered it before, we know that this email actually points to whatever account we saw it before. And so we need to do something with basically all the emails for this particular account, because this entire account basically is not its own entity. We need to basically make sure it's pointing at the other account that it should, which is not itself, because it's not a disjoint set, okay? Now, again, that's kind of a little bit more on the high level stuff, but you can kind of understand maybe how we're going to start to approach this, at least hopefully. You can kind of start to understand how we might approach this programmatically, even if you can't think of the code, right? Okay, so this is kind of the implementation of the union find data structure, right? We implement the union find class. This is why this problem is a little bit tricky, is because you actually have to implement this yourself also, and then use it. But very briefly, we'll just discuss it, right? And it's okay if this is the first time you're seeing this. It is a little bit confusing. I can't even lie to you. It was for me also. I learned this not too long ago, okay? But remember this, a lot of this is just set theory stuff that you may have learned in discrete math. If you didn't take discrete math, it's okay, right? Just make sure you're reading up on stuff by yourself also. And over time, it'll make more sense. But basically, we implement the union find class, right? And initially, we set the number of nodes as their own parents, right? So, basically, initially, every element is its own parent at the start, right? Like I was talking about before, basically every entity belongs to itself, because we're assuming they're disjoint sets initially. and because they're not merged, that's what we have to do, right? So initially we just assume everything's kind of a disjoint set. That's kind of the point of union find, right? And find here is basically we return the root parent of the set that X belongs to. And this is useful when we actually want to do the merging, right? Because let's say you have let's say you have like a set Y that belongs to a set X, like they're merged, and then there's a set Z, right? Well, you don't want to merge technically Z to Y. You want to merge it to the root parent, which would be X. If we have a disjoint set Z, right? We don't want to merge it to the Y because that's a child of X. We actually want to merge the Z to the X. I know it's a little bit confusing, but you always want to merge to the root parent, basically. So anyways, the find we're not actually explicitly going to use down here. It's actually just used here, where we do the union, which is where we merge the child and the parent that we pass in, right? And so this is basically what we're going to use to merge the two sets, right? Or the two accounts in our example down here. And so we find the root of the child using find child, that method, and then we're going to find the root of the parent using find parent, right? And we're going to make the root of the child point to the root of the parent, effectively merging the two, right? So yeah, the parent of the child is going to point to the parent of the child is going to point to the actual parent we pass it in. So yeah. And again, if this doesn't make too much sense to you, make sure you just keep studying the union find stuff. It really isn't. I don't think it is really hard at first, but it will make sense over time. Just practice these problems. There are quite a few of them out there. Um, and honestly, it's mostly just the fact that you have to implement this stuff by yourself also before you use it. So you're kind of forced to understand. I mean, you're forced to understand it, otherwise nothing makes sense. But I hope I explained that okay, right? Especially the illustration that I had, where basically everything is its own entity, but when we find something, a union between the two, we have to do the merging, right? Okay, so we got the explanation out of the way, a lot of kind of the understanding stuff out of the way. Now we're going to do the implementation. I'll try and go slow here just so you kind of understand. So we're going to create an object, right? UF. And it's going to be created from the length of the accounts, right? For the union find data structure. Okay. Now we're going to need something else called the email group. It's going to be a default dict of a list, right? And here, right? What this hash map is going to do is we're basically going to have the index of the account, right? And it's going to map to a list of emails, right? So the index of accounts, and this is going to map to a list of emails. So this right here is basically what we're going to use to construct our merged emails later on. Okay, and that will help us for our output. Okay, so this isn't too important right now, but it will be later, and you'll see why. Okay, now this is the email to account stuff that I was talking about, where I was saying we're going to create a hash map, right, where the email is the key, and it should map to the index of an account. Okay, and so we're going to first of all iterate through this, right? We have the account index, and we have the actual account when we iterate through accounts. Okay, so let me put this in a comment just so we can kind of make sense as we go, so you don't get too confused. Okay, so what we're doing is we're basically iterating through these accounts, okay? And at every given point, when we go here, we want to know, okay, what is this account, which is all this, and what index, right? Index 0, index 1, index 2, and index 3, sorry. Got to do that. And we need this because remember logically how we're doing these union find stuff, right? Every account is basically its own node, and they belong to themselves unless we find some overlap, in which case we have to merge those two nodes, basically. Okay? So we're getting these accounts, right? But we also need to go into the accounts and actually get the emails, right? So we're going to say for email in email to name, or sorry, not in in accounts. Accounts. And we're going to say 1:, right? Because the reason we have to do 1:, is because we care about the emails. we don't care about the names, right? So we're going to skip the 0th index. We want to start at the first index onwards, and this is inclusive, right? So at the first index onwards for each of these accounts, that's what we care about. Because we care about the emails. We don't care about the names right now, okay? Because we're just basically going through the accounts and seeing if there's common emails, okay? So when we're going through these accounts, right? And we're going through these emails, email by email, right? What do we care about? Well, we care about if that email is in our hash map already. And if it is, we need to basically do some type of merging. Now, if it's not in our hash map, it means it's the first time we're encountering that email. So we're just going to map that email to whatever the account index that we're on, okay? So we're going to say, if the email is an email to account, right? We're going to say, and let me also, I did explain this stuff, but I'm going to write some comments here just so a little bit easier for you also, right? The first value is always the account name. Then the emails. So skip the first value, which is the 0th index. Okay. Now here, if this exists, the current account index and the one we inserted previously need to be unioned, right? I'm trying to write my comments. Yes, okay. So if the email we are on right now is in the hash map, it means we encountered that email somewhere before, right? So what do we need to do? We need to take the account where we saw it before and the account that we're on now, and we need to union those, right? We need to merge these accounts, okay? So we're going to say uf.union, and remember our union, right? The child should point to the parent. So the child is actually the account we're on now, and the parent should be where we saw the email the first time, right? So this account that we're on now is basically going to point to whatever the account that we saw the email first in is, okay? So remember, the first parameter is actually the child. So this should just be the account index, and then the parent should be where we saw this email the first time. So we're going to say email to account, and we're going to say email. Okay. Now, if this email doesn't exist in our hash map, it's the first time we're seeing it, so we can just put it in our hash map, right? Pretty simple. So we're going to say email to account, email, account index. Okay. Now, I know I should use an underscore because it's Python or whatever, but I'll just write it like this. I think it's easier to read. Hopefully that doesn't bother you too much. Okay, so now we populated our hash map and we unioned where we needed to. Okay, so what do we have now? Well, what we have now is a hash map, right? Full of emails and account indexes, right? So what we're going to have to do is we're going to use the email group to basically group the emails together, okay? This is how we're going to do this. Oh, sorry, slight little error. Let me fix this. We don't want to iterate through all the accounts, just the account that we're on, right? The emails belong to the specific account that we're on, so make sure you remove this S here, okay? Okay, now I'm going to show you something, right? And this is very important for the union and kind of how we're going to do this grouping, okay? And I'm going to do this with a print statement just so you kind of understand how this works, okay? So we're going to iterate through this hash map, okay? So we're going to say for email, the account index in email to account.items. We're going to iterate through the hash map, right? And we're going to print some stuff, okay? So we're going to print the email that we're on, right? We're going to print the account index that it belongs to. Okay, so we're going to say account index, right? And then we're actually going to print something which is going to be the leader, right? So basically, who is the leader of this particular account? And we're going to say uf.find and we're going to pass it the account index. Okay. So I just want to show you something really quick by doing that. So remember, like when we're going through example 1, John Smith appeared in this account index 0 and account index 1. So when we encounter John00, for example, here, this is the first time we saw this email. So it belongs to account index 1, right? Right? Because this particular email here only showed up once, which is here. However, this should not be here. It should be up here, right? Because this John Smith here was seen up here. So technically all these emails need to be put up here, right? Yet this only showed up once. Okay. So it belongs to the account index 1, which is the second John, right? Index 1. So naturally it says in John belongs to account index 1, yet you can see its leader is actually 0. Interesting, right? And that's because of the union that we did, right? Because this account here, despite this email belonging to this account index, which is index 1, we unioned this account to this account, right? So technically this account, which is index 1, points to this account, which is index 0. And that's why technically the leader for this email is index 0. Despite the actual account index being 1, its leader is actually index 0. And so that's why we need to do the merging now, kind of manually. Or I should say maybe not merging, but the grouping of the emails. Okay? So the way we're going to do this is we're going to say, and I can scroll down, by the way, if you're curious on seeing everything, right? So the way we're going to do this now is we're going to say leader equals uf.find account index, right? So we're going to set the leader, and then we're going to say email group, right? For this particular leader, we're going to append the email. Okay, so we're basically appending all the emails to the actual proper account now, right? So because, for example, this John should not be here, but it should be up here. And so we're actually appending it to its proper leader. Okay, pretty simple. And as you can see, by the way, this John Smith Gmail only shows up once, right? And that's what we should expect though, right? Think about it. That's what we should expect. If John Smith belongs here and it belongs here, but we're doing a merging, of course it should only belong up here when we do the merging, right? We don't want John Smith to show up twice. We want to merge these accounts, right? And so this is kind of where we're doing the actual merging. The union is basically where we set up the nodes to basically point in the right direction. You can think about it like that. And now this right here that we're doing when we're iterating through the hash map is we're actually creating the actual grouping of the emails that we want. Okay. So I hope that's actually a little bit helpful, especially since I print this stuff out for you. Okay. I know this problem is not easy, but I'm trying to make it as easy as I can for you to understand. So hopefully you're following along okay. Okay. And now down here is where we have to return the string of strings properly, right? And that's why we did this email group stuff here. But remember, when we print this, we want to return the emails, but we want to return the name first, right? The name should be first and then the emails, okay? So we're going to say for account index emails in email group dot items. And remember the leader is the key, right? Which is the account index, right? Because when we're doing uf.find account index, we're basically just finding what the proper index. When we're basically getting an email and what is the actual proper index it should point to, right? Rather than account index 1, it should point to 0, right? And so that's why we have to put this first. Okay. So we're going to say name is going to be accounts, the proper account index that we're pointing on, and the 0th index, right? That's how we get the name. Because remember, we have the for any given email, we have the proper account index now of where it should be, right? For example, this John here is actually not pointing at index 1, but index 0. So we're going to point at index 0. We're going to go, okay, we're going to go to this account, and we're going to get the 0th index, which is what? The name, right? The first element. Okay, so we're getting the name, and then we need to get the actual emails and append that after the names. Okay, so we're going to say answer.append, right? We're going to append the name and then all the emails. So we're going to say email group now index. And down here, we should return answer. And again, remember, we have to sort this. It's kind of annoying, but that's just how they want the problem. The actual account themselves don't have to be given in any particular order, but the emails have to be sorted in a specific order. So we have to do it like this. So I think that should be it. I messed up some syntax somewhere. Okay, let's submit this. And boom, that's the problem. I really hope I helped you with this. I tried going as slow as I can, explaining everything as simply as possible. Very quickly, right, this is the union find stuff that we implemented, the data structure. And then this is the stuff, right? Go through the emails, basically populate our hash map, union wherever we need to. Then we basically find the leader of all the emails and basically write out our emails to the specific account they should point to, and then we return the actual sorted emails to the specific account they should actually be at after we merge and everything. So yeah. Oh, I think I was testing something earlier. That's why I had that. My bad. It should return down here anyways, but so it shouldn't give you an error. But anyways, I hope this helped. I will say this is probably a problem you should come back to. Not that easy, honestly. I've seen a few videos to help me when I first did this, and everyone says the same thing. It's not that. This you could potentially argue it's a hard problem, especially if you've never done union find. Definitely a bit on the harder side, but I hope I helped you. And yeah, I'll see you in the next one. Peace out.